So I've got this Moons motor here, brushless DC with it's got the wire saving feedback. So it's got A naught, B naught, and index naught, +5 and ground. But also on the same feedback cable, they'll transmit the UVW Hall code at power up or reset. So this tells us, where is the shaft of the motor with respect to the magnets in the coil, so that we can use the drive to commutate. In this demo, I'm showing just using Sano Denki wire saving method, but I believe inside of here is a Tamagawa feedback, and I'll be getting engineering to develop the Tamagawa specification. And anyways, this is APV with an easy board, and I've got my separate 24-volt V logic and then my high voltage line. And so these motors are wound. You can get 100 volt, 200 volt sort of range. They do have a 24-48 volt, so higher currents, lower voltage, or this is a low current, high voltage motor. So we'll take a look at this motor here. It's an SM040, and we see this this motor in Europe. I got this motor for an application that's local, but they decided that they don't like this wire saving, so they got the regular Halls. But you can see, the voltage for the motor. This is like a 75 volt typical, but they do have a winding for 24. Rated speed, maximum theoretical speed. Be careful of side loading on this. You don't want to wake up in a pile of brass. And continuous rated current in amps, volts RMS per kRPM. So just watch the units here. You got your inertia, kilogram meter squared times 10 to the -4. Brake. It's got a brake option. And so you get your basic low-cost OEM style connectors, little flying lead with connectors on it. And you can see they also have a servo catalog here. So we'll take a look. There is the full specification for the motor in here, but we're going to look at the feedback device. So they have A and A naught with an index. It's a full pulse width. And if you want the super, accurate edge, you got to come off of the U channel. And then this has Halls UVW. So this is the cable with a lot of wires on it. And you can get a circular or the square wire. This is typical on the OEM. And so you see the wire colors, good, red for plus and black for ground. UVW, just use U plus, V plus, W plus, tie back the minuses. But the differential for the encoder, that's important. And the shield, make sure the shield connects to the drive end and not to the motor case. And this is the motor I have, is the E4 feedback option. Same motor coils, just a different feedback. And again, get your accuracy with the U channel. This is part of the transmission on power up. You get the position of the magnets so that you can then commutate, and there's less wires. So you can see they consolidate with the Tamagawa type wire saving feedback, A naught, B naught, but it also has U, V, and W in there, and +5 and ground again. So less wires, hence the name wire saving. And I think, there's also an absolute feedback type. I saw this as an NDAT type of feedback on this motor, NDAT 2.2. Let's take a look at this with CME, and you'll see in the basic setup, right now CME just shows the Tamagawa wire saving, but when you select the Tamagawa wire saving, you get these Halls in there by default. And of course you put the lines, which is 2,500, which gives us 10,000 counts per rev. That's pretty good. And then we can, you load the data for the motor on the motor screen. I'm just going to reset this so that it can read the halls on power up or reset. But you got all this moons, wire saving, model number. The E4 is the wire saving number. It's an 8-pole motor with the max speed. The back EMF works out to be pretty close, volts per radians per second and Newton meters per amp peak. It's got a large resistance, so this is definitely a higher voltage winding. You know, so if you're going to deliver the continuous rated current, you're going to need some voltage for that. Plus, if you're going to go 6,000 RPM, so really 6 times 24, plus some IR drop. So take a peek at the current here. It's a low current, so high voltage. I'd say this probably runs better on 150 volts if you want to hit that 6,000 RPM. Maybe change the velocity limit if you're going to go fast. Yeah, there's a warning here. Like, hey, you've only got 24 volts, so you're not going to go that fast. Too much IR drop. But yeah, it said 75 volts, but I'd say, you know, maybe we ought to go for a higher voltage here. So we'll take a quick peek at the manual phasing. And again, you know, this is from power up or reset. So these Hall decodes, you know, it's a simulated now because it's just going off of the encoder. So the important thing is that we capture the Hall state on power up properly. And I see I've got a Hall offset here. Yeah, I think the new firmware will do a better job of catching this capability here. I believe they were 60-degree Halls. So this is just for experimentation purposes. Yeah, so I lost the phasing on this one. Let me reset it again, see if it can capture it. So the new firmware will be adapted to this Tamagawa style instead of the Sano Denki. So we'll make sure that we have the latest firmware in order to do this properly. So that's just an initial setup. I'll be sending this motor to the design engineers. So we've got some customer opportunities which are demanding this. So the next time I'll show it operating. Anyways, they do have the incremental encoder with Hall option available, but that's like, well, now you got to wait 8 weeks for your motor, and they only have the wire saving in stock. But I'll be sure to update this video as soon as I get the new firmware feature. So yeah, guesstimate firmware for the plus drives at 4.80 or 4.72 perhaps. Okay, thanks for watching.